Mr. Guy German is a co-founder and CEO of Okibo Limited. He is an electrical and computer engineer and entrepreneur who co-founded Okibo for the purpose of introducing efficient autonomous robots to the construction industry. Guy worked with robotics, electronics, and software since high school and served as an officer in the Israeli intelligence unit. To talk about the challenges of developing an autonomous wall finishing robot, let's all welcome Mr. Guy German.
Thank you very much, Ella. Hi everyone. Good afternoon for the people in Singapore. So I'm going to talk a little bit about the challenges of developing robots for the construction industry and how different it is from developing robots in general, which is always challenging. So I think I won't take long just to remind everyone about the challenges of the construction market that leads to the idea of or the need of developing robots for the first place. And so a lot of spokesmen before me have mentioned the huge shortage of skilled professionals, a growing problem. And of course, this is not only the fact that there are not enough working hands to complete the jobs, but also cause lots of other problems like the direct rising of labor costs, project delays, which of course also translates to financial problems. And also other people mentioned the qualities and inconsistencies, productivity, and people that are getting hurt while doing the job in an unsafe environment. So smart automation is obviously the right way to go for this huge industry. No doubt about it. And there's no better way to automate process than using robots, which are smart automation. And so that's pretty much the trivial way to go. However, developing high-skilled robots for real-life challenges, not as a proof of concept or demonstrating capability, is not always simple. It goes on and on. It is a funny video, but of course the problem is not funny. It's serious, and the industry needs practical solutions. And so, what is before the construction robots were actually right now starting to be market available? There were basically three kinds of commercially available mature products. So the first section was AMRs or AGVs, which are robots working in production lines or in warehouses in very sterile environments. Usually these areas are marked with all sorts of fiducial markers and so forth. And the robots are carrying some sort of payloads within this sterile environment going from A to B, and that's a solved problem. The other kind of robots that were out there and that we have experience for them for decades are field robots that are for military use. Lately, there are lots of solutions for the agriculture technologies, fruit picking, and so on. And so those robots are for outdoor, doing some even smart operations with manipulators, but a very definite sector, and I will later on explain what the difference between them and the realities in the construction industry. And the third kind are very accurate industrial robots, which usually requires programming and are doing the same task over and over again, even if they have some sort of sensors, like in the production line to feel when the bottle is coming, or some sort of vision to support the work. It is pre-programmed and still very, very structured and sterile environment still. So these are the three kinds of commercially available solutions. But construction robots have different kind of requirements, which often contradict and makes the design of the robot more difficult. So the robots, of course, in a construction needs to be mobile. It cannot be static like the industrial robots. They also need to reach the area where they're working. And if we're talking about indoor environment, you need to reach from floor to ceiling, but you need to go through a doorway and you need to be mobile. So you need some sort of way to have telescopic and capabilities to allow the reach. It's not a production line, it's not a warehouse, so maneuverability is also a big problem. Working in a construction site, which is dirty, you have some countries more than others, but in some places you can have glass and nails and debris on the ground, which you need to pass even to reach your working area. And you have to be stable in order to do accurate work of fabrication. So stabilization is contradicting, maneuverability, because maneuverability, for example, requires the design of having rubber wheels like the field robots, which are out in the field. But when you have that, the whole system is not stable. And if it's not stable, it cannot reach high and it cannot have accuracy and so on. Of course, it needs to be safe, which is common to any robot anywhere, but makes it even more difficult in this harsh environment. It also needs to be autonomous. So just having a robot is not enough. The reason it needs to be autonomous, I mean, according to my view at least, it is the fact that the problem that in the first slide was the lack of people working in this field. So just replacing people that are doing one thing with smart robot operators is not going to solve the solution on a large scale. So the robot needs to do the operations themselves. And it's a changing task all the time, so it makes the problem even bigger. It has to have indoor navigation, so no GPS. Professor Shen showed a robot with very impressive knowing how to take a beam and actually deploy a robot according to a given map. But it's not always easy in a construction site, which keeps changing and adapting a digital model to the real world where it changes every day is not an easy task. So navigation indoor in a construction site is a big challenge. It has to be collaborative, which is only part of the robots needs to do this. Some of the robots have the luxury of working in a sterile environment, but in construction site, there are many people working there. So it needs to take attention and not only stop working when there are people around, but actually know how to work in a collaborative way. Of course, accuracy and strength and agility, and it has to be durable. So all this is makes designing robots, practical solution robots for construction sites, pretty challenging. But most importantly, there are two things that without them, it's just going to be a project for YouTube. It's not going to be actually a product ever. And the first thing is reliability, because a construction site cannot offer exactly the same thing as, by the way, as the industrial robots cannot afford not working, cannot afford downtime a lot, because projects needs to keep their schedules. So that's the first thing. But even more important than all the other things, in order to have a practical solution, it has to be easy to operate. And so that's just like 3 words, easy to operate, but that's behind that, it's basically all the technology that is required from a construction robot, because the tasks in every building is different. In the same building, the same project, every room is different, and the same room is different from one day to another. And you cannot have an engineer programming a robot to do the work, because you don't have enough engineers, and of course you don't want to replace construction workers with engineers operating robots. You want to have robots to be able to do the jobs smart by themselves. And you need to have an easy way to operate the robot. So not having a person in the loop that is required to be part of the job. That's the big trick behind the construction robots. So Philippe mentioned, I think, at least half of this slide or even more. So I won't go into describing what kind of the exact companies in each area, but we have today a lot of startups and a lot of big companies that are working on construction robots. Some of them are in production already in the market. Some of them are still in the process of being developed. And you saw the bricklaying robots. There are very interesting rebar works, not only the companies that are in this slide, but also others. And drilling, besides Hilti, we have Princeton's and Hyundai. Of course, concrete 3D printing buildings is a very major vertical for automation in the industry, and scanning and marking with facade works. Philippe mentioned paint up, and heavy machinery is basically, so you saw build robotics, but actually all the big manufacturers are working on autonomous excavators and autonomous tools for as well as so there are, I think, more than a dozen companies having autonomous heavy machinery works. And in our vertical, AIBotics is doing a wall finishing robot. So also there are plenty of startups and companies. You saw Transforma and mentioned Canvas and La Compagnon from France and others, as you can see in this slide. So it's a very vibrant market. So a few words about, like I mentioned, a lot of requirements from construction robots, but to do a wall finishing robot, we're doing plastering, sanding, joint stapling, roller painting of ceilings, other applications, but only in the finishing areas. There are some unique requirements for these robots as well. So synchronization is one. So it's not enough to have some sort of manipulator and a mobile platform. They need to be synchronized. For example, one application that we're now working with a customer is doing a roller painting of ceilings. So while the robot is moving, the manipulator is painting ceiling in order to be very efficient. So everything needs to be synchronized. So that's a challenge. And of course, a robot, not only for plastering or for finishing robots, but for other robots in the construction, there needs to be some sort of sensors to have force and torque inputs for the system. And of course, the closed loop algorithms to control the robots while doing the work. But finishing robots also needs to handle carrying and handling wet materials, which is sometimes not the easiest thing in the world. And of course, these robots needs to have awareness, have very good perception of the 3D geometry around them, or the indoor structure, with high localization capabilities, as I mentioned before. So just having BIM, which is not always there, but even if you have BIM, is not really helpful. You actually need to sense the world and understand it. The robots, the system needs to do it if we want to take the person out of the loop. So that's another big technological challenge. Maybe just a few words. I won't take a lot of your time about our robot. So all of the above are just relating to the mechanical, to the kinematic challenges of the robot, or most of them were directing to this area. So that's the left part, to have a robust robotic platform. But other than that, there are the actual work needs to be done. So we've developed our own pattern perception algorithm for the system, and the autonomous work planner and path planner. So after you actually understand the world and you have a robot that has the capability to do the work, to actually have the robot program itself to do the work. So that's the autonomous capability. That's the secret sauce. That's the big trick. in order to have eventually a widely deployed and scalable solution in the market. So I'll end up with showing you a short video of our robot spray painting. So again, it's not the only application that is dedicated for this platform, but that application is now available right now in the market.
Thank you so much, Guy. That was Mr. Guy German, co-founder and CEO of Kibo Inc.